Hello, welcome to a new video on number theory. In this video we are going to discuss two important results. Here we are going to find the Jacobi symbol values of two numbers. The first number is -1 and the second number is 2. So let us consider capital P that represents an odd positive integer. It's a composite number. In general, we take a composite number. It's an odd positive integer. With respect to this integer, we can find the Jacobi symbol value -1 bar P and 2 bar P. First result says that -1 bar P equal to -1 raised to raised to P minus 1 by 2. And the second is 2 bar P equal to -1 raised to P square minus 1 divided by 8 actually. Here you have to correct, this is a writing mistake. Here we have instead of 2 we have 8, we have to take 8. Okay, then we can one by one we can derive these values, but before starting our derivation, let's write the given number, the composite number, as the product of prime numbers. Here we allow the repetition of prime numbers. Okay, we take the prime number, the given number, composite number P equal to P1 into P2 into etc to Pm. We write that P equal to P1 into P2 into etc to Pm. We allow the prime numbers to repeat. That means we don't combine the prime numbers that repeat as in the case of prime power product representation. And by allowing prime numbers to repeat, we write that product, and then in the first case, if you want to prove the value for, if you want to derive the value for -1 bar P, we can write that product as 1 minus P1 minus 1. See the first prime number here. After taking the product, you can you can rewrite that first prime number as 1 plus P1 minus 1. See, 1 can be one additional 1 is given, and that is subtracted then to get to P1. And the second number P2 will be written 1 plus P2 minus 1. Likewise, up to the last number it is written 1 plus Pm minus 1. So we have the product P1 into P2 into etc to Pm equal to 1 plus P1 minus 1 into 1 plus P2 minus 1 into etc to 1 plus Pm minus 1. And that can be written as pi, the product, the short representation pi from I equal pi, where I varies from 1 to m of 1 plus in bracket Pi minus 1. See, the second part will be written in bracket together by taking the two numbers together, Pi minus 1. Okay, then we are now going to expand that. This product we are going to expand. So the first term will be 1, and then second term will be the sum of sum of all possible second terms. So that is summation from I equal to 1 to m of Pi minus 1, and plus the third term will contain the product of the second terms taken two at a time. That is the sum of the product of all second terms taken two at a time. Product of the second terms in the expression. This is we consider that it is in the form 1 plus x or 1 plus I, where I varies from 1 to m. So then we can consider the sum of the products by taking two at a time. That's summation from I equal to I and j varies from 1 to m, but I is not equal to j is the condition used, that of Pi minus 1 into Pj minus 1. And that can be continued up to the last term will be the product of that pure product of all the second terms, that is P1 minus 1 to P2 minus 1 etc to Pm minus 1. And we can also see that since pi is each pi is an odd number, so pi minus 1 is an even number. And what is its consequence? Its consequence is that you can take here from the second term, you can take 2 outside. See, 2 is common to the second term, but here coming to the third term, 2 into 2 will be there. You can separate 2 from the first term and another 2 from the second term, so 4 can be separated from the third term. And then from the fourth term you can take a product of 3 2's, that is 2 into 2 into 2 can be separated, that is 2 cube can be separated. Likewise you can separate 2 raised to m from the last term, but we want to make it sure that we can take 4 as factor from the third term onwards. Considering all the remaining terms from the third term onwards, you can take 4 as a factor. You can separate 4 as a factor, but that means excluding the first and second term on the right side. As a result, you can write that expression, the given number p is, then you can rewrite it as p is congruent to 1 plus the first term plus the second term mod 4. You can write, so p is congruent to 1 plus summation from I equal to 1 to m of p I minus 1 mod 4, and that means you can that means you can transfer 1 to the left side and write p minus 1 is congruent to summation from I equal to 1 to m of pi minus 1 mod 4. Then since this quantity this congruence is divisible by 4, that means p1 minus 1, when the left side is subtract from the right, when the right side is subtracted from the left side, you can divide the entire quantity by 4. So you can divide, suppose you divide the first and the second term, the first and the left hand side and the right hand side both completely by 2. You can write that it is mod, that congruence is then mod 2. You can write that's done in the next step. So we dividing both sides of the congruence by 2, and you can write p minus 1 divided by 2 is equal to then 1 by 2 into actually this expression, but it 2 can be taken inside, so summation from I equal to 1 to m of pi minus 1 divided by 2 mod 2. Instead of 4 you can write mod 2. Here the missing term is number is 2, and therefore you can convert this, you can rewrite this expression in this form by considering this right hand side as the first on the left hand side. You can write that summation from I equal to 1 to m of pi minus 1 divided by 2 equals 2 into k, and this k is some suitable integer, some matching integer, 2 into k plus p minus 1, this quantity p minus 1 divided by 2. Okay, and then you can after that you can consider the Jacobi symbol minus 1 bar p is then taken, that can be equal to applying a previous result, applying the property of the Jacobi symbol. I think this is the second property here applied. So my 1 bar p equal to minus 1 bar p1 into minus 1 bar p2 into etc. to minus 1 bar p3 etc. to last term is minus 1 bar pm. Okay, that can be then written equal to the first in the first bracket. You can write the equivalent quantity minus 1 raised to pi minus 1 raised to p1 minus 1 divided by p1 minus 1 by 2, because here we can apply the value of the legendary symbol minus 1 bar p, where p is a prime number. If p is an odd prime number, minus 1 bar p equal to minus 1 raised to p1 minus 1 raised to p minus 1 divided by 2. So using that result, you can replace all the quantities in the bracket by the corresponding powers and get that minus 1 raised to p1 minus 1 by 2 into minus 1 raised to p2 minus 1 by 2 into etc. to minus 1 raised to last one. This one is pm minus 1 divided by 2, minus 1 raised to pm minus 1 by 2. Then you can combine this product and write that minus 1 raised to summation from I equal to 1 to m of pi minus 1 divided by 2. Okay, but referring the previous step, since this quantity equal to 2 into k plus p minus 1 divided by 2, you can substitute, you can replace this quantity by that equivalent quantity and get that minus 1 raised to 2k plus p minus 1 divided by 2. When we factorize that into 2, minus 1 raised to 2k, and this one is first return, minus 1 raised to 2k into minus 1 raised to p minus 1 by 2. But minus 1 raised to 2k becomes plus 1. It's because this number is an even number, so its effect is nullified. That means we get plus 1 here, so plus 1 into, in multiplication, its effect is the neutralized. Thus minus 1's effect is neutralized. We get that the answer equal to minus 1 raised to p minus 1 by 2. Finally, minus 1 raised to p minus 1 by 2. That is the end of that part. Next to prove the second part, that is 2 bar p, means to find the second value for the number 2 bar p. We have to consider p square. Instead of p, we write here p square. We take here p square, and p square equal to p1 square into, considering that product of primes, p1 square into p2 square into etc. to pm square. But each pi square can be written equal to 1 plus pi square minus 1. So we add 1 and then we subtract 1. We add 1 and we subtract 1 to each pi square, and that is together, the three quantities are together taken in bracket, and then by considering pi square as one representative of that product, member of the product, you have to write pi from I equal to 1 to m. Actually here that is missing. So here we want to write pi, the product symbol pi, where I varies from 1 to m, and that's a mistake. So after that we want to expand it. As in the previous case, we can expand that, and then see that you can refer that expansion, this step, a similar expansion, a similar kind of expansion is done here. See, that step is very similar to this one. Here we have expanded that, and this product is here is expanded. Just like that, we expand here the current product. That expression we will expand that. Then we get 1 plus a summation from I equal to 1 to m of pi square minus 1 plus summation where j equal to y is not equal to j up to m, where I and j varies from 1 up to m, but also the condition I not equal to j is used, and pi square minus 1 into pj square minus 1 plus etc. The last time is also not here, not written here. Last time is plus p1 minus 1 into p1 square minus 1 into p2 square minus 1 into etc. to pm square minus 1 is the last term. But that you can note that pi is an odd number, so pi square minus 1 will be divisible by 8. Since pi square minus 1 is divisible by 8, that you can verify. You can see that pi square minus 1 is congruent to 0 mod 8. Therefore, when we come back to the expression, when we refer this the expanded terms, you can see that excluding first and second term, all the remaining terms can be divided by 8 into 8, that is 64. You can divide all the terms from starting from 3 up to the last term. From the third term up to the last term, you can divide every sum by 64. Okay, therefore this is this way you can write that therefore p square is congruent to 1 plus summation of first and second term. 1 summation from I equal to 1 to m of pi square minus 1 is mod 4. Mod 64. It is mod 64. That is 8 into 8, 64. 8 square, 64. And therefore, when we let's suppose when we think about dividing both sides by 8, let's divide both sides by 8. Then p square minus 1 by 8 is congruent to the sum divided by. But before that, we transfer 1 to the left side. Then p square minus 1. After that, we divide both sides by 8 is congruent to summation from I equal to 1 to m of pi square minus 1 divided by 8. Mod 8. Then we consider 2 bar p equal to 2 bar p1 into 2 bar p2 into etc. to 2 bar pm. Okay, referring that product representation of p. And we also know that the Legendre symbol number value, Legendre symbol value 2 bar p in general, 2 bar p, where p is an odd prime number. we know that that value equal to minus 1 raised to p square minus 1 divided by 8 when the legendary symbol value is when p is an odd prime, then we have that minus 1 raised to p square minus 1 divided by 8, that value. Then using that, in each case inside the bracket you can use that number, the corresponding number inside the bracket to replace the quantity, and you can write that minus 1 raised to p1 square minus 1 divided by 8 into minus 1 raised to, say this should be into multiplication, it's not addition, into minus 1 raised to p2 square. Here we can convert this into, we can write this quantity as minus 1 raised to p2 square minus 1 divided by 8, etc. Last one is minus 1 raised to pm, this number is pm, so pm square minus 1 divided by 8, and then you can combine that and write minus 1 raised to summation from I equal to 1 to m of pi square minus 1 divided by 8, and using this using the fact here written, which is written here, you can write this quantity equal to summation from I equal to 1 to m of pi square minus 1 by 8 is equal to 8 into k plus p square minus 1 by 8, because it is this the difference of these two numbers is divisible by 8, so you can write that this quantity, the summation, the sum of these terms equal to 8 into k plus p square minus 1 divided by 8. What happens finally, you can write it as the product of two powers of minus 1 raised to 8k into minus 1 raised to 2 p square minus 1 divided by 8, but you know that this quantity, the first quantity, will be then positive plus 1, and so plus 1 into the remaining quantity is minus 1 raised to p square minus 1 divided by 8, and thus we get the finally that this value. So that's the end of that the second part. Okay, thank you.